Okay, first order differential equation. Okay, suppose you have a differential equation of the form dy dx plus p of x y equal to q of x. All right. Now, you might look at, because this is so common in calculus, what is the easiest thing to take the derivative of? d dx of e to the x, right? Because that's just e to the x again. Okay, but I want to try to make this look like the product rule. And in order to do that, I have to get a p of x, okay? Linear function p of x. Okay, so what I'm going to do is, to get this function p of x back, I'm going to integrate. So I'm going to use e to the integral of p of x dx, like that. Okay, now let's look at this. If I multiply everything by this e to the integral of p of x dx, okay, so I will have e to the integral of p of x dx multiplied by dy dx plus y times p of x, which I will explain in a moment, multiplied by e to the integral of p of x dx. See, it doesn't matter if I put p of x times y or y times p of x. It's the same thing. Okay. And then that's equal to q of x multiplied by e to the integral of p of x dx. Okay, so let me write that again. E to the integral of p of x dx times dy dx plus y times p of x times the integral of times e to the integral of p of x dx equals q of x times e to the integral of p of x dx, like that. Okay, so there we have it. I just multiplied by everything by e to the integral of p of x dx. Okay, now this kind of looks like the product rule right here. Actually, it is the product rule. Okay, first times the derivative of the second, which is y. First times the derivative of the second, which is y, plus the second y times the derivative of the first. See, when you take the derivative of this, you have an inside embedded function, so you use a chain rule. So y times the derivative of the second, which is p of x times e to the integral of p of x dx, which equals q of x times e to the integral of p of x dx. Okay, this can be written as a product rule. Okay, so you have the integral of p of x dx, okay, times y, okay, differentiated with respect to x. Use the product rule. First times the derivative of the second, which is the second up here, okay, plus the second y times the derivative of the first, which is the derivative of this. And that is just equal to q of x times e to the integral p of x dx. Okay, Now, if I integrate both sides, integral of this dx product times of y with respect to x, and I integrate this side as well. With respect to x. Okay, when I integrate, I'm just going to undo this function here. Okay, so all I'll have left is e to the integral of p of x dx times y equals integral of q of x times e to the integral of p of x dx with respect to x, right? All right, so now to isolate y, all I have to do is divide both sides by this e to the integral of p of x dx. Well, that's just going to give me y equals e to the minus integral of p of x dx times the integral of q of x times e to the integral of p of x dx with respect to x. Okay, so that's going to be the general solution to that differential equation. And I use the multiplier e to the integral of p of x dx. Okay, so now I'm going to apply this rule to a true situation, okay? Let's suppose you have a differential equation. Now you have to get it in this form. You have this differential equation. For p of x, use 2 over x times y equals sine 3x over x squared. Okay? So now I need to find a multiplier. So I'm going to let this be my p of x, because I get it in the form dy dx plus p of x y equals q of x. So how it matches? P of x is here. So I'm matching up everything. Q of x would be this thing here, this function here. Okay, so I need a multiplier to simplify that equation so that I can solve it. So what I'm going to do is I'm going to pick p of x equal to 2 over x. All right, so I'm going to take the integral of e to the integral of, I'm just going to take e to the integral of 2 over x dx, like that. That will be my multiplier. Okay, but what is the integral of 2 over x dx? The integral of 2 over x dx equals 2 times the natural logarithm of x. Okay, 2 times the natural logarithm of x, which can also be written as the natural logarithm, of x squared. Now I want to show you what happens when you get your multiplier. You're gonna have e to the natural logarithm of x squared, which just equals x squared. How do I know that just equals x squared? How do I know? Well, let me show you something, an extra bonus here. Okay, if you have e to the natural logarithm of x squared, and you set that equal to y, you set this natural logarithm of x squared equal to y. Okay, so in other words, you're going to have e to the y equals x squared, because this is to the base e. So raising y to the e power gives the x squared back. Well, isn't that interesting? Because I set this natural logarithm of x squared equal to y. Okay, I set the natural logarithm of x squared equal to y. So if the natural logarithm of x squared equals y, then this is e to t to the y, right? But I just proved that e to the y equals x squared. So e to the natural logarithm of x squared equals e to the y, which just equals x squared. And that's how I got that. So this is going to be my multiplier, x squared. So now I'm going to multiply everything by x squared on top here, this equation here, and see what happens. Okay, so I have x squared dy dx plus x squared multiplied by this is just going to be 2xy, but I'm going to write it as y times 2x, and I'm going to set that equal to, if I multiply this by x squared, it's just going to be sine 3x. Okay. This is better. This is more clear, easier to see. Okay, so you have x squared dy dx plus y times 2x equal to sine 3x. Now I can apply the product rule. Okay. This is going to be the first times the derivative of the second, which if you wrote it the other way, the y would be over here. So first times the derivative of the second, which is y, plus the second y times the derivative of the first, x squared, the derivative of the first is 2x, right, equals sine 3x. Okay, so that's pretty clear. So now I'm going to write this as, this is the product rule, so dx of x squared times y, right? First times the derivative of the second, which is y, plus the second, y, times the derivative of the first, which is 2x, equals this sine 3x, right? Okay, now I'm going to integrate both sides. If I integrate both sides with respect to x, what's going to happen? Well, it's going to undo this differentiation, and you will have, or I will have, x squared y equals the integral of sine 3x dx. And that's going to be minus cosine, because derivative of sine is positive cosine. The integral of the sine is minus cosine. So that's where I messed up on the last video. I forgot to put the minus sign. So we're going to have x squared times y equals minus 1/3 cosine 3x. And if you want to put the plus c here, you can. Okay, so you could say the general solution is just going to be y equals x to the minus 2 times minus 1/3 cosine 3x plus c. And if you're interested in seeing how I integrated this, the integral of sine x, sine 3x rather here. Okay, I would let u equals 3x. du equals 3 dx. So that means dx equals 1/3 du. And if I substitute that back in, if I substitute this u back in, I'm going to have, I'm going to be integrating 1/3 of sine u du, because I substituted back in for du. Remember, 1/3 du equals dx. That's what I found. Dx equals 1/3 du. So I substitute that back in, and I'm going to get minus 1/3 cosine u plus a constant. But what did I originally let u equal to? 3x, right? So the answer will still be minus 1/3 cosine 3x plus c. And the solution, the general solution to this differential equation up here that I started with, this one, the general solution to this differential equation, dy dx plus 2 over xy equal to sine 3x over x squared, the general solution to that is going to be y equals x to the minus 2 times the quantity negative 1/3 cosine 3x plus c. Okay, so I corrected it. And that's the general solution.